Hello class 10 students. Regarding chapter 11, the human eye and the colorful world. Today at first I will teach you one topic regarding advanced sunrise and delayed sunset. Look at your textbook now. You may know, may not be, the sun is visible to us about 2 minutes before the actual sunrise and about 2 minutes after the actual sunset because of the atmospheric refraction. Due to the phenomena of atmospheric refraction, we do not observe the actual position of the sun except only when the sun is directly overhead. When sun is directly overhead at the top, perpendicular you can say, then we can see the exact position, the actual position. Otherwise, we will not get the actual position due to the atmospheric refraction. When a ray of light enters the Earth's atmosphere, it continuously bends towards the normal. As it moves from optically rarer medium to optically denser medium. Because already you heard varying density of different layers in the air, as well as you heard about optically rarer medium and optically denser medium also. So whenever the ray of light is traveling for a long distance, everywhere density in the air may not be equal in all the layers. Somewhere it will be optically rarer medium where the speed of light can travel faster, you heard somewhere. Somewhere it is optically denser medium also. So ray of light, it is to bend continuously. Ray of light, it is to bend continuously as soon as it is entering into the Earth's atmosphere. So whenever a person is looking at the sun, he is not getting actual position, he is getting the apparent position. And the apparent shift in the direction of the sun from its original direction is nearly 0.5 degree, and the time difference between actual sunrise and apparent sunrise is 2 minutes. This makes the sun visible 2 minutes before it's come out of the horizon. The same result is obtained during sunset also. The sun can be seen up to 2 minutes after its actual setting. So a day appears to be longer by 4 minutes. So for your understanding, you please remember that the advanced sunrise and advanced sunset, that will differ 2 minutes. That's why a day will be longer. 2 plus 2, 4 minutes. In this case, this is the horizon. Here the sun before rising. So when the ray of light is entering from the sun into the Earth's atmosphere, it is to bend slightly. Whoever is standing here, he will observe the sun not in this position. He will observe the sun as if sun is coming from this direction. That's the apparent position of the sun. That's why before 2 minutes, before sunrise, before 2 minutes, sun it is to come out. Here we can observe the sun. Same thing will happen during sunset also. Now let me talk about scattering of light. In class 9 you heard about Tyndall effect also. We'll talk little bit. The interplay of light with objects around us gives rise to several spectacular phenomena in the nature, like blue color in the sky, color of water in deep sea, reddening of the sun at sunrise and the sunset are some wonderful phenomena which you are familiar. In earlier classes, as I told about class 9, you have about colloidal solution, colloidal particles. Whenever the beam of light will pass through a colloidal solution, it is to scatter. It is to scatter. But if you are taking true solution, that Through the true solution, the ray of light, whenever it will pass in a dark room, it may not scatter, you may not observe the shiny path through which the ray of light is going. So, Tyndall effect, which you heard in class 9, is that effect whenever any colloidal solution, if you are using in a dark room, transparent glass you have taken, colloidal solution you have taken, maybe the solution made by starch, milk, blood, yeah, whatever. Whenever the ray of light is going through colloidal solution, through which path it is to move, it is to shine. It is to shine. That's known as Tyndall effect. That's known as Tyndall effect. So the phenomena is seen when a fine beam of sunlight enters a smoke-filled room also through a small hole. It is to scatter light and make the particle visible also. Sometimes you can observe. Tyndall effect also can be observed when the sunlight passes through a canopy of a dense forest. Dense forest, and if the sunlight is passing through a canopy of a dense forest, we can observe Tyndall effect. The path of light will shine, and through which path the ray of light is coming, moving, whatever, there all the particles will be clearly visible. That's about your Tyndall effect. Mostly colloidal solution will proceed this Tyndall effect. Here we can observe Tyndall effect through colloidal solution. Now next topic, why is the color of the clear sky blue? Look at the textbook properly. The molecules of air and other fine particles in the atmosphere have size which is smaller than the wavelength of the visible light. In future you will learn about wavelength. These are the most effective in scattering of light of shorter wavelength at the blue end than light of longer wavelength at the red end. You heard that white color, it is composed of, it has 7 constituent colors. It is composed of 7 constituent colors: violet, indigo, blue, green, yellow, orange, red. So most effective in scattering of light of shorter wavelength at the blue than light of longer wavelengths at the red end. The red light has a wavelength about 1.8 times greater than the blue light. Don't forget. So when sunlight passes through the atmosphere, the fine particles in the air scatter the blue color, that is shorter wavelength, more strongly than the red. That's why we can see the color of sky is blue. So the scattered blue light enters our eyes. If the earth had no atmosphere, there would not have been any scattering. So the sky would have looks dark if no atmosphere. But since atmosphere is there, when the ray of light is coming towards us, at that time it is to scatter blue color light first, because it has shorter wavelength than the red color. So sky appears dark to the passenger flying at very high altitude also, as scattering is not prominent at such cases. But when you are standing in this earth's surface, sitting in this earth's surface, if you are observing the clear sky, then blue color is scattered more. That's why you can see the color of the sky is blue. Again, color of the sun at sunrise and sunset. One activity is given. You can go through this activity also. If you can observe if you can do this activity by taking place a strong source of you can say white light at the focus, converging lens, etc., etc. You can do this activity also to understand about color of the sun at sunrise and sunset. Here a little bit I have to tell you. If you can do this experiment, that is an arrangement for observing scattering of light in a colloidal solution. This is your colloidal solution. Ray of light is passing, you can say. One cardboard is kept, inside hole is kept. Some ray of light will stuck towards the cardboard. It will not go out, and some will pass through this hole. Here just like mirror, your glass is kept and one screen is kept, you can say. Whenever the ray of light is going, as soon as it will pass through the lens, if you are using lens, then it is to converge and it will meet at one point. So you can see this color here. So you can observe the blue light from the 3 sides of the glass tank, you can say. This is due to the scattering of short wavelength by the minute hole of colloidal sulfur particles. We are using colloidal sulfur particles here. So when you will observe the color of the transmitted light from the fourth side of the glass tank facing the circular hole, it is interesting to observe at the first the orange red color will come, then bright crimson red color will be coming on the screen. You can go through this by yourself. Next, the final topic. This is the observer. Sun is nearly overhead, you can say. Less blue will be scattered, but when sun will be this side, blue scattered away, sun appears a bit reddish, you can say, sun when it is near the horizon. So here I have to tell you something. Earlier whatever activity is there you can go through properly. That will demonstrate the scattering of light that helps you to understand the bluish color of the sky and the reddish appearance of the sun at the sunrise or sunset. Light from the sun near the horizon passes through a thicker layer of air and larger distance, long distance it is to travel in the Earth's atmosphere before reaching our eyes. So when the light from the sun overhead would travel relatively shorter distance, but when the sun is either left or right, it will travel more distance. Normally at noon the sun will appear white as only a little of the blue or violet colors are scattered. Near the horizon, most of the blue light and shorter wavelengths are scattered away by the particles. Therefore, the light that reaches our eyes is of longer wavelength. That's why it can give rise of reddish appearance of the sun. That's why we can see the sun color is reddish. Color is reddish when it is near the horizon. Even when it is going to set also, we can see reddish appearance of the sky. So this is our chapter, the human eye and the colorful effect. So please go through this. For better understanding, you can read this. I don't need to go for activity right now here, but you can go through properly. You will understand more. So normally, sunlight is a white light. It is composed of 7 constituent colors. You can say violet, indigo, blue, green, yellow, orange, red. Which color it will be scattered, which will come to our eyes because of shorter wavelength, longer wavelength. We can see the color of the sky also. So normally the color of the sky is blue, because blue color will be having shorter wavelength and it was to scatter fast. But early in the morning, blue color scattering during sunset, blue color scattering will be slight less. In that case, sky is to appear a bit reddish. So please go through this properly. Bye for today.